Right, continuing from where we left off the first video, we proved, let's just write it over here, that triangle AOD is congruent to triangle COB. Okay, go check that video out if you haven't seen it yet. Okay, that was A. Let's just write this a little bit nicer. A, O, and D. Okay, is congruent to COD, congruent three horizontal lines. The second part, B. Okay, so we're going to do B now. And in B, we need to prove that AOB, so let's go highlight this for ourselves in another color. AOB is congruent to COD. Right, so the triangle on top and the triangle at the bottom, we want to prove the congruency there. Okay, so exactly the same like the previous video, we're going to prove congruency with side angle side. The way we're going to choose that is in those two triangles, right? Those triangles that we've highlighted, that we've colored in those two triangles, you can see that you got are given two of the sides. The third side you don't have, so you can't go with side, 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 but you can find the side, or the angle rather, that's inscribed between those two sides. So it's possible for us to say that O1 is equal, all right, let's say that again, O1 is equal to O3, still vertically opposite angles are equal. Okay, great. We've mentioned it in the previous video, but I removed it from the slide, so I'll write it again. AO is equal to OC. This is given. Okay. Then as well as OB equals to OD, also given. Right, so what we have is we have an angle that's in between two sides, so we can say therefore triangle AOB is congruent, so we're going to write three vertical lines to triangle COD. And again, our reason is going to be side, angle, side. So we've proven our congruency. Okay, that's only been 2 minutes, so let's go into C as well. So there are different methods or different ways that we can prove parallelograms. In fact, at this stage, there's going to be 3 that we're going to discuss. Okay, let me maybe just get rid of some of this. Let's get rid of all of this. All of this, I want to get rid of, and that also. Okay, let me actually just move this up a little bit higher. So we have the fact that those two triangles are congruent. Okay, we've proven those in our last or the previous video and this video. So for C, we want to be able to prove the parallelogram. Okay, so in order to prove a parallelogram, there are 3 theorems. Okay, theorem 1. Theorem 1 tells us that if you have a quadrilateral, so there's 4 sides, quadrilateral, and if you can prove one of 3 things. Number 1, if you can prove that opposite sides are equal, then that shape, without a doubt, is a parallelogram. Okay, so maybe we can try that. Okay, or still theorem 1, if you can prove opposite angles are equal, then that thing's a parallelogram. Okay, or even this theorem 1 still, if you can prove that opposite sides are parallel, that thing's a parallelogram. Okay, so if you can do one of those, then you have proven a parallelogram. So for us, with the information that we currently have, let's go and try and prove that our opposite sides of our shape that we're dealing with in this question are equal. Okay, the way that we're going to do this is like this. Right? So based on our congruency, so based on these 2 statements, we know a ton of things, right? If I look at our first statement over here, so this one over there, and I look at the order of the letters, I know that AO equals CO. Okay, again, first and second are going to equal to each other. I know that OD, OB, OD, OB, they are equal. Okay, the order of the letters tell me all of this. Then I also know that AD and CB, AD and CB, they are equal. How do I know that? The order of my letters, okay? So if I can look at my pictures, AD is this one. BC is this one. So of the greatest shape, the quadrilateral, ABCD, we, because of our congruency, now know that AD is equal to CB or BC, right? So this statement over here, this one we're going to need. So we're going to say, because of the congruency, so we're going to say triangle AOD is congruent to triangle COB. Okay, so that reason that we wrote, this reason is valid for all three of these statements. Okay, however, these first two statements we already know because that was given information. So as much as we know it because of our congruency, we don't need it here, so I'm going to get rid of it. Okay, the statement that I've got over here, this one we do need, okay, to prove our parallelogram. This one gives us the fact that our opposite sides, right? So this one over here, let's not get rid of that, so let's just highlight it maybe in something. This one over here and this one over here, we now know are equal because of those congruent triangles. Similarly, let's look at our second statement over there. Okay, so now if I look at this one, that second statement, again the order of the letters. Okay, so A and B is going to or A and O rather is going to equal to CO. OB is going to equal to OD. AB is going to equal to CD. Okay, so all of those I know because of the order of my letters. So I'm going to say that AB is going to equal to CD. Okay, the order of the letters. Go look at the picture. So AD, that or AB rather, is the one on top. DC is the one at the bottom. So now in our quadrilateral ABCD, because of our congruency, we know that AB is equal to DC. Let's write that down. AB is equal to DC. We've got that. We need to write our reason rather, which is going to be triangle AOB is congruent three horizontal lines to triangle COD. Okay, how do we know this again? The order of the letters gave us that fact. So because of those two things, we can say therefore our quadrilateral ABCD, therefore ABCD is a parallelogram. How do you know it's a parallelogram? So this reason is to be over there, but I don't have space. We're going to say opposite sides are equal. The fact that the opposite sides are equal proved that that shape is a parallelogram. Okay. In fact, that is only using theorem 1. So we could have used theorem 2 as well. Okay. So let's talk about this quickly. Theorem 2. So if you have a quadrilateral and you have your diagonals in, if you can prove that your diagonals bisect each other, that means this part and this part are equal, as well as this part and this part are equal. If you can prove your diagonals bisect each other, then you have also proven that that is a parallelogram. And in fact, in this question, they gave us the fact that that one and that one is equal. So we know that the one pair of diagonals is bisected. Similarly, the other one, they gave us that those are equal. So our other diagonals also bisected. So just by nature of that given information, that is enough reason already to say that that shape is a parallelogram. However, when we did this in class, this is part of the exercise before theorem 2. So they actually wanted you to use the congruent information to prove your parallelogram. Okay.